In this video, we'll be proving that tan derivative of tan x equals to sec squared x. And so let's use the first principles. So the limit as h approaches 0 of f of x plus h minus f of x divided by h. And that's by the first principles. This is equal to limit as h approaches 0. If I sub in my tan, I get tan of x plus h minus tan x divided by h. Now, I can rewrite this in terms of sine and cos. And so if I take out the 1 over h, that will become tan x plus h minus tan x. Okay, and it will be equal to the limit h over 0 of 1 over h. Now I can rewrite tan as equal to sine over cos. Okay, so tan x equals to sine x over cos x. And so that will be sine x plus h divided by cos x plus h minus sine x on cos x. Right, now let's bring these two fractions together, so making the same denominator. So it will be 1 over h, and that will be cos of x times sine of x plus h minus sine x times cos x plus h, all divided by cos x times cos x plus h. Alright, now before we move on, please make sure you like and subscribe to this channel for more of these kind of videos. Okay, so now let's use compound angle formula to expand the top values. So we get equal, so we know that sine x plus h equals to sine x cos h plus sine h cos x, and we know that cos x plus h equals to cos x cos h minus sine x sine h. Yep. And there will be limit as h approaches 0 of 1 over h, and just sub it in those values. So cos of x sine x cos h plus sine h cos x, close brackets, all divided by cos x plus h, and some more space, minus sine x times cos x cos h minus sine x sine h, close brackets, all divided by cos x plus h. Alright, and what we can now see is that we can cancel some terms off, so the cos x sine x cos h, that can be cancelled out. So then we're just left with cos squared x sine h plus sine h sine squared x, okay, all divided by cos x plus h. Now I can take out the sine h here, I can factorize that out. That will equal to limit as h approaches 0 of 1 over h of sine h brackets cos squared x plus sine squared x, close brackets, all divided by cos x plus h. Now I know that cos squared x plus sine squared x, that equals to 1 by the trig identities. Right, so this equals to 1. So then we're just left with equal to the limit as h approaches 0 of 1 over h of sine h divided by cos x times cos x plus h, close brackets. Right, and let's put the h's together now. So we have 1 over cos x plus h, and times the limit of h over 0 sine h divided by h. Okay, and this obviously by limit rule, I can separate these two limits. Now this limit here we have done before. If I draw a graph, a sine graph, for very small values of h, it's a linear graph, right? So sine h divided by h, so sine h is approximately equal to h. So this fraction here would equal to 1. So sine h over h would equal to 1 for very small values. So then we're just left with the limit of that times 1. Alright, so now let's evaluate this limit here. Let's draw a cosine graph. As h approaches 0, so that means as h gets very small, the graph approaches 1. Okay, so cos of x plus h would then approach cos x. Okay, and I'll show you a proof here. So cos of x plus h, now we can use compound angle formula, right? So if we expand this, we get cos x cos h minus sine x sine h. And because we're trying to find a limit, so the limit is h approaches 0 of cos x plus h equals to cos x, and the limit of h approaches 0 of cos h, so we're just concerned about the variable h, and the same with the other one. So minus sine x, the limit is h approaches 0 of sine h. Now if I draw my sine and cosine graphs, as h approaches 0 for each one, the cos of h approaches 1 and sine of h approaches 0. So by substituting those values in, we get the limit of cos x plus h equals to cos of x times 1 minus sin x times 0. So we're just left with cos x, and that's our answer. Alright, so now we know that is cos x, so that we get the derivative equals to cos x, 1 over cos x times cos x. That will be 1 over cos squared x. And we can also rewrite this as the derivative of tan x, that it will equal to sec squared x. I hope you learned something. See you next time.